All right, so we have example 1 done. Now let's go to example 2. Same type of problem, except now we're starting with 3.75 grams of nitrogen and going to ammonia. So I'm going from nitrogen right here to ammonia, NH3, okay? So I'm starting with my 3.75 grams of nitrogen that goes out front, and if I map it out, I'm going to start here at grams, and I'm going again to grams. So I'm going to take that same route, first going from mass to moles, moles to moles, and then moles to mass. So my first step in going from mass to moles is to use that molar mass, again on the bottom, and 1 mole on top. The molar mass of nitrogen being 28.02, because I took, again, N2, or N, and multiplied it by 2. Next, I have my mole bridge to go from 1 mole to another, with my substance that I'm starting with going on bottom, 1 mole of N2, the substance that I'm going to, ammonia, going on top. And where did I get this mole ratio? From my coefficients. Okay, notice my 1 mole of N2 comes from right here. My 2 moles of NH3 come from right here. That allows me to get to here, but I need to get to mass again. So to go to mass, 1 mole goes on bottom, the molar mass goes on top. So I divide in solving this. If the number's on bottom, I'm going to divide, and then multiply, and then multiply. And when I do that, please do it with me on your calculator. You should get 4.56 grams of NH3. So there's another example of a 3-step stoichiometry problem, going from grams of one substance to grams of another. First, again, my molar mass of nitrogen going on bottom, 1 mole going on top. Then I cross the mole bridge with nitrogen going on bottom, 1 mole of N2, and 2 moles of NH3 going on top. And then I go back to grams, but I'm going to grams of NH3, so 1 mole of NH3 goes on bottom, and 17.04, the molar mass of NH3, goes on top. And what I get for my answer is 4.56 grams of NH3. So what does this tell me? This tells me if I have 3.75 grams of nitrogen, how much ammonia could I produce? 4.56. All right, let's go down to example number 3. Example number 3. Here's the same thing, except I need to balance my chemical equation. So to balance my chemical equation, I'm going to start with carbon, 1 carbon, 1 carbon. How many hydrogens? 4. Here there's 2. So what do? I add a 2 to get 4 hydrogens here as well. And then I do oxygen. Well, on this side of the reaction, I have 3 oxygens. On the product side, I have 2 plus 2 is 4. I can't balance that. Remember, if you get to oxygen and it won't balance, you double the coefficients that you've added and start over. So what I'm going to do with this 2 is double it, and I'm going to make it a 4. Okay? Now I'm going to start over. So now how many hydrogens do I have here? 8. To get 8 hydrogens on the left side, I need to add a 2. And that makes 8 hydrogens. But that messes up my carbon. So carbon now has 2 carbons. So I'm going to need to add a 2 over here. So now I have 2 carbons, 2 carbons. And now I last have oxygen. Oxygen on my product side, there's 4 here and 4 here. That's 8. On my reactant side, I have 2 here and 2 here. That's 4. It's not balanced. So 2 plus what equals 8? Well, hopefully you can say 2 plus 6 equals 8. And now I have my balanced chemical equation with 2 carbons, 2 carbons, 8 hydrogens, 8 hydrogens. Oxygens, I have 2 plus 6 is 8, and then 4 plus 4 is 8. Everything's balanced. All right, so now I'm ready to start the problem. To start the problem, what I'm given goes out front. 52.4 grams of methanol. What mass of water is formed? Okay? So what is methanol? Methanol is this alcohol right here, CH3OH. So I'm going to start with my 52.4 grams of methanol. and I'm going to go towards water, grams of water. My three-step problem. So first, I'm going to go from grams to moles with the molar mass again going on bottom, 1 mole going on top. Then I need to do my mole bridge, going from methanol to water. To do that, again, I use my coefficients. Methanol going on bottom, what is the coefficient of methanol? 2. What is the coefficient of water? 4. So 2 methanols is going to go on bottom, 4 waters is going to go on top. That's my mole bridge. Then I have my last step going from water to grams of water. 1 mole of water always going on bottom, the molar mass of water 18.02 going on top. So in this case, I'm working my way across. Remember, if a number is on bottom, you divide. So I'm going to take 52.4 and divide by 32.02. If a number is on top, I'm going to multiply. So then I'm going to multiply that number by 4. But I also have a number other than 1 on bottom here, so then I'm going to divide by 2 and then multiply by 18.02. So I take 52.4 divided by 32.02 times 4 divided by 2 times 18.02. And what I get is 58.98 grams of H2O. Again, another 3-step stoichiometry problem. Once you're done with this, let's go ahead and turn it to the back. Give you a minute to jot this down. All right, we can flip it to the back. On the back, same thing. I'm gonna take a break here and have you try the next 3. And then I'm gonna run through them so that you can check your answers. To get you started, let's again review balancing. 2 chlorines, 2 chlorines, 2 S's, 1 S. So I'm gonna need to add a coefficient there, and now I have my balanced chemical equation. All right, so let's go ahead and pause the video. Why don't you take 5 to 10 minutes and try to do these next 3 problems. All right, hopefully you've got a chance to try these next 3 problems. Let's go ahead and check our answers. Here I'm starting with 20 grams of S2Cl2, and I go from grams to moles, and then I cross my mole bridge. So I'm going from S2Cl2 to chlorine. What's chlorine? This right here. So what is that mole ratio? 1 S2Cl2, 1 chlorine on top. That's my mole ratio. And then I go to grams, so 1 mole of chlorine. The molar mass of chlorine, 70.9, because I'm taking chlorine times 2. So in this case, I'm going to divide. The 1 over 1, you don't really need to do anything. If you want to multiply by 1 and divide by 1, that's fine, but you can skip it. 20 divided by 135.02 times 70.9 gives me an answer of 10.5. Hopefully you did that one okay. The next one, I'm starting with 20 grams of S2Cl2, and instead of going to chlorine, I'm going to sulfur. So first I went from grams to moles, and then from moles of S2Cl2 to moles of sulfur. Now in this case, again, 2 moles of sulfur equals 1 mole of S2Cl2, which I got for my balanced chemical equation. And then I go from moles of sulfur to grams of sulfur. Once I divide, multiply, and multiply, you should have got an answer of 9.5. All right. Last, I asked you to do question 3. So here I go ahead and balance 1 lead, 2 nitrates, 1 nitrate, I add a 2, 2 sodiums, 1 sodium, I add a 2, and that makes 2 I's and 2 I's. There's my balanced chemical equation. Now the question says, if you start with 35 grams of PbNO32, how many grams of precipitate will form? So it doesn't directly say the product, but it says the precipitate. And hopefully you remembered a precipitate is a solid. So I'm going from PbNO3 to PbI2. Okay, I'm going from lead nitrate to lead iodide. So I'm going to start with my 35 grams of lead nitrate. the molar mass going on bottom, 1 mole on top. Then I cross the mole bridge, 1 mole of lead nitrate on bottom, 1 mole of PbI2 on top, and then I go back to grams, but I use the molar mass of PbI2 on top. So I hopefully divided and multiplied, and I got an answer of 48.7. Hopefully, again, you did this correct. If you didn't, see where the mistake was made so you don't make it again on your homework. All right, last thing on the note guide. On the bottom, we're not always going to be going from grams to moles to grams. Sometimes we're going to be doing volume or particles. Now to remember, volume, 1 mole equals 22.4 liters. So if I'm working with a volume, like in the last example problem, I start with 4.56 liters, and first I go to moles, and then moles to moles, and then back to grams, because the question says what mass of carbon will burn. So in this case, I'm starting with 4.56 liters, first going to moles with my 22.4 going on bottom, 1 mole on top, and that takes me right here. And then I go from moles of CO2 to moles of carbon. What is that ratio? 1 to 1. I got that from the balanced chemical equation. Then I'm going to go from moles of carbon to grams of carbon with my molar mass of carbon on top. So in this case, I'm going to divide and multiply. What I should have got for an answer is 2.44 grams. All right, there's another example of a stoichiometry problem going from liters to grams. All right. I am going to assign just the front of the worksheet. Hopefully, again, you finished the note guide and you can try a few more problems on the worksheet. On the worksheet, these vary from 1 to 3-step problems. The first one, number 1, I'm starting with 3 moles of zinc, and I'm going to moles of hydrogen. So hopefully, if you look at your cheat sheet, moles to moles is 1 step, where all I need is the mole ratio of zinc to hydrogen. So in this case, I'm starting at moles of zinc, multiply by 1, and I got my answer of 3. So number 1 and 2 are very similar, where they're just 1-step problems going from moles to moles. But when I get to number 3, it's back to a 3-step problem, where I'm starting out with 25 grams of potassium chlorate, which is KClO3, and going to grams of potassium chloride. So first I go from grams of KClO3 to moles, then from moles of KClO3 to KCl, that's a 2 to 2 ratio, and then I go from moles of KCl to grams of KCl. So in this case, I'm dividing. If you want to multiply and divide by 2, that's fine, but again, they cancel. And then I multiply by 74.55 and get an answer of 15.2. Take a minute and copy this down so that you have your examples. So what I would like you to do for next class is hopefully have your note guide and the front of worksheet 7.1 done. Hopefully, again, you have your note guide and the front of worksheet 7.1 done. If you have any questions, please come see me during HIP or before or after school. For questions, next class we'll be continuing with more stoichiometry problems. Hopefully this was a good introduction for you. I'll see you next class.